Okay, welcome back to Number Systems, how we count. I'm assuming you've seen part one, which was the decimal numbering system. If you haven't already watched that little video, go back and watch that, because that's how we count normally in everyday life. That'll help you get a feel for how the numbering systems work, because now we're going to talk about how computers use numbering systems. We're going to talk about binary. All right, if you remember, decimal had 10 digits we could use. Binary only has 2 possible digits, which works great for computers because computers only know 2 conditions, on and off, 1 and 0. Okay, so with the binary numbering system, let's say we had a number like this, 1010. I know that number is worth 10 in decimal. I can say 1010 means nothing to me, it means a lot to a computer, but if I want to convert it back to decimal, I say 10. And that, again, is based on binary bit positions. Just like in decimal, we have bit positions. If we start on the far right, now remember, we only have 2 digits, so we're going to be doing base 2 instead of base 10. All the way on the right, 2 to the 0 power equals a 1. Now I know that's a 0, but the bit positional value is 1. If I come over 1 to the first power equals 2 times 1, 2. If I come over to the third position, 2 squared equals 2 times 1 equals 4. This position, 2 to the third power equals 2 times 2 times 2 times 1 equals 8. Notice as I go up, 1, 2, 4, 8. As I go up, it doubles every time. That's a consequence of being binary. The next bit positional value would be 16. The one beyond that would be 32. The next one above that would be 64. And the one above that would be 128. I've got 1, 2, 3, 4, 5, 6, 7, 8 bit positional values there. In the world of binary, in the world of computers, 8 bits equals 1 byte. Okay. 8 bits is 1 byte. In order to convert this to decimal, we take the bit of 1, meaning that bit is on, we look at the positional value, and we add up the positional values. So in this case, we'd have a 2 plus a 4. No, I'm sorry, it's kind of skewed a little bit, plus an 8 equals 10 in decimal. Now don't confuse that with binary 2. That is a decimal 10. If I add this bit and leave that bit off, I've now got my 2 plus 8, plus I add a 32. 2 plus 8 plus 32 equals 42. I know that whole number is now 42. This is taking the binary that the computer understands, converting it to decimal that we understand. That's going to come in very important in part 4 of this little series, dotted decimal.